All right, so for number 8, here's what we know about number 8. I'm just going to do B. Like I said, A is a little tougher. So it says he pushes a 30-kilogram door, so we know the mass of the door is 30 kilograms. In part A, we figured out that the width of the door, which I am going to arbitrarily call L, or no, we never use L, do we? We usually use R. So we'll use R, the quote-unquote radius of the door. Did it turn out to 0.8 meters? Am I remembering right? Am I saying the word remember right? I think I said remembering. Yeah, 0.8 meters. Okay. It's a door, so that means that our I is 1/3 mr squared. All right, so let's see. It says, where on the door should his force of 10 newtons, so the force of Roy is 10 newtons, where on the door should it be applied if he wants the door to reach 0.6 radians a second in 0.6 seconds? So what is that 0.6 radians per second, you guys? Angular velocity, but that's just the final, right? What was the initial, presumably? 0, right? And then it tells us that we want this to occur in 0.6 seconds, right? No. Ah, I'm dying. All right. Everybody good up to there? Questions, problems? So ideas about where to start, AJ? Sir? Okay, well, hey guys, please. So again, we've got two equations for torque. I alpha, FD. The question wants to know where the force has to go. So what am I really looking for, you guys? D, right? So, use the top one to find the torque, and then plug it in, right? Okay. So let's see, I need to find my I. So I is just 1/3 mr squared. So that gives you a third of 30 is 10 times 0.8 squared. It gives you 6.4 kilogram meters squared if you plug in your numbers there. Cool. All right, and then we can find our alpha by using omega f minus omega I over t. And it conveniently turns out to be 1. Just 1, right?
Yeah, it's 1.
In part A it was. In part B it turns out to be exactly 1. Radians per second squared. Everybody good? So now we can find our torque, right? Because we know how much inertia we've got. We know how much acceleration we want. So our net torque is I times alpha. 6.4 kilogram meters squared times our alpha, which was 1 radian per second squared. And so you get 6.4 kilogram. No, you don't. You get 6.4 Newton meters. Everybody good up to there? So now we can find our distance. Holy moly, this is a weird looking towel. I didn't want it to do that. I was in the middle of doing stuff. To go back, press the orient or right click button. Oh, darn it.
They're all like isolated countries.
It is a satisfying little ding it gives, though. All right, so as I was trying to say before my board physically assaulted me, we had just found our net torque, FD. So our net torque is 6.4 Newton meters. Our force is 10 newtons. We are looking for D. So divide both sides by 10 and you get 0.64 meters. And we are done. What else, guys? Anything else? I did not mean that to sound quite as final, because we have 10 minutes, so if you have questions, we might as well ask. Or I guess 7 minutes. Little stupid.